Okay, just testing out a different video style in the recording here. So, actually, let me close the door. Okay, let's see now. So we want to look at it's similar to what happened earlier. We have the formula here for sec inverse, and we want to arrive at the cosec inverse formula. Okay, so let's start off with y equals cosec inverse t. That means cosec of y equals t. That means 1 over sine y equals t. That means sine y power minus 1 equals t. That means bring down the power, reduce the power by 1, and multiply by the inside derivative, which is sine y, becomes cos y, dy dt, that's equal to 1. So dy dt, that would equal sine squared y over cos y. So if we remember here that y equals cosec inverse t, or cosec y equals t over 1. Remember, cosec is hypotenuse over opposite. So that's t, and that's 1, I think, and that would be root t squared minus 1. Cosec is 1 over sine, which is hypotenuse over opposite. So hypotenuse and opposite. Okay. So then that means dy dt. Oh, and I nearly forgot my minus. Dy dt would be minus sine squared y, which would be 1 over t squared, over cos y. And cos y is root t squared minus 1 over t. Aha. So I think this is how we get the absolute in, because yeah, that'd be 1 over t, or absolute t, root t squared minus 1. That's dy dt. So then integrating, now the reason here is that I'm actually not 100% sure why it becomes an absolute and not just t. Must be so, oh, well, because, okay, t has to be a positive. It's the hypotenuse. So I guess, yeah, I guess it's because of that. Yeah. So then that means y, that's cosec inverse t, equals this plus the constant of integration. Plus the constant. And again, just like last time with the sec inverse t, there's no reason to think that that constant is the same. It's a different function. In other words, sec inverse does not equal minus cosec inverse, because it might be tempting to say that, but actually what's a little bit confusing here is those c's aren't actually the same. They're different constants. So that's why it's a mistake to think this. You can see this by just putting in different values. It's not going to equal. And the reason is because the C1 is not necessarily equal to C2. That's the reason why. In 405, what's wrong with this integral is that the limits, the integration 1, 2, is not a subset of the domain. And the domain for this is all the real numbers except for -1 and 1, because you cannot divide by 0. And a similar situation, 406, -1 to 1 is not in the domain. And the domain for this is all real numbers except for 0, -1, and 1. So that's the reason why. I wonder what they say for the answer. It's called an improper. What one is this? 405, I can check. Oh, well, that's another reason too. You can't go beyond 1. So actually my domain is not quite what I said. The domain here, we can't go beyond 1, so the domain is -1 to 1, so that's definitely no good. And it's actually not all real numbers here. The domain again is -1 to 1 except 0. So it's because of the 0, really, and it's because of like 1.5. Okay. So it looks like some tech questions next. All right.